Welcome back to the Deep Dive. This is the Inside Quantum AI podcast from Loop Quantum AI Labs. And you can find all our research over at loopquantum.ai.
And today we are really getting into the core of what we do.
We have to, because there's one big question that frames everything for us right now. Industrial scale qubits. Is it all still just hype, or is it finally a reality?
Yeah, that's the billion-dollar question, isn't it? And
Yeah.
based on our internal research, the answer isn't a simple yes or no. It's complicated.
Okay, so let's break it down. When people hear quantum tech, they tend to lump everything together. But really, we're looking at three distinct fields.
That's a crucial distinction. You have quantum computing, or QC, which gets all the attention. But you also have quantum communication, QCom, and quantum sensing.
All using the same physics, but for totally different things. And even inside quantum computing, there's a huge split.
A massive one. Between analog and digital computers. Digital is your gate-based model, the one people think of. But analog, things like quantum annealing, it's a different beast entirely.
And the hardware landscape is getting crowded. On the superconducting side, you've got companies like Rigetti, IQM.
Then there are the neutral atom systems from Pascal and Quera, and of course, trapped ion machines, which is where IonQ and Quantinuum really shine.
And we sit on top of all of that in the application software layer of the value chain. So let's get back to that central question, hype versus reality.
Well, the data shows we've crossed a threshold. Quantum computers are not just a hype product anymore. We are, right now, seeing vendors sell actual production-ready machines with stable qubits.
Which is the entire reason we came out of stealth in 2025.
Yep.
Honestly, we couldn't do our work until the hardware was actually there to run it on.
Exactly, because what we're focused on at Loop is quantum native AI. We're not interested in just simulating things.
Let's pause on that. Quantum native can sound like a buzzword. What do we actually mean by that?
Think about it like this. If you try to run a classical neural network on a quantum chip, you're fighting the physics of the machine.
You're forcing a square peg into a round hole.
A quantum hole, yeah. To really use the power of the quantum mechanics, you have to build your AI models from quantum first principles. Abandon the neural net. But to do that, you need deep, raw access to the hardware.
And that's not something you get from a standard cloud API. You need your own machine.
You absolutely do. Now, we have to be realistic here. This is a big but.
A very big but.
While we have production machines, the qubit counts are still relatively small, and the engineering hurdles are they're massive.
So every vendor is in this race to find the sweet spot, right? To balance stability with a higher qubit count.
And we're seeing some amazing progress. Look at D-Wave's annealing systems. They're pushing for quality and getting something like 4,400 qubits with 20-way connectivity.
That is an enormous amount of stable computational real estate. I mean, compared to just a few years ago, it's night and day.
It really is. But here's the catch. These machines are absolute divas.
The biggest divas in tech. They're hypersensitive.
The site specifications are completely non-negotiable. You can't just plug it in. To keep those qubits stable, the system has to be cooled to about 15 millikelvin.
Which, for anyone wondering, is about 180 times colder than interstellar space.
Colder than space. Plus, you need zero electromagnetic interference. Total isolation from any vibration. It's a huge logistical challenge.
So how are they making progress so quickly with systems that sensitive?
Well, the manufacturers have a secret weapon. They're using AI to tune the machines.
So, classical AI is helping build the quantum computers.
In a way, yes. It creates this incredible feedback loop, bridging the gap between the theoretical physics and the physical hardware. It allows for a level of calibration that, frankly, a human engineer just couldn't achieve.
And that stability is what finally lets our team get to work. We can stop working on simulators and start building with quantum principles directly.
Which is why we believe the next generation of AI has to be developed now. The machines are finally ready for it.
So to answer our opening question, industrial scale qubits, hype or reality?
It's reality, but it's a reality that demands some of the most rigorous engineering on the planet.
And if you want to be part of building that reality, we're hiring. We're growing our interdisciplinary research team right now.
We need people in quantum control theory, adiabatic quantum computing, even computational biology and biomolecular mapping. Check out the open roles at loopquantum.ai.
It does make you wonder, though. If AI is helping build the quantum computers and quantum computers are going to run the next generation of AI, at what point do we just step back and let them talk to each other? Thanks for joining this deep dive. We'll catch you on the next one, releasing on X.